another modality, which is a fixed angle east to west tracking. This kind of tracking whereby between 7 o'clock in the morning up to 12 o'clock in the noon, the panel is directed to the eastward, and then afternoon in the noon, the panel is directed westward at a particular angle, which is calculated using equation 3. But equation 1 was used to determine the beam solar radiation at based on the horizontal beam solar radiation. This is the beam solar radiation by a tilted panel, and this one is the radiation, HB, the radiation on the horizontal panel. So this is the relation which enable us to find the radiation as received by a tilted panel from the solar radiation that is falling on the horizontal panel. And in this case here, we have used the beam or direct solar radiation. Here, RB is the beam radiation tilt factor, which is calculated using equation number 2. And whereby cos theta, where theta is the angle of incident, in this case is calculated using this equation. And then theta z is the zenith angle, which is calculated using that equation that is shown there, where omega is our angle and delta is the declination angle, which is calculated using this equation, where n is the number of day. So n is start from 1 to 365. As I said earlier here, equation number 3 is used to find the what we call a fixed angle. This is the angle used in the east-west, fixed angle east-west solar tracker. That is the first part in the theoretical, theoretical analysis using solar radiation data. So the solar radiation data used to give us the HB, which is the solar radiation or direct solar radiation incident on the horizontal panel, so that we can find the HBT, which is the solar radiation incident on the tilted panel at particular angle. In the second part is the experiment, which was used to determine the influence of tracking by using a panel and a fabricated manual solar tracker. So here the tracker was tilted at angle ranging from about 90 degrees at sunrise and sunset. And also IV checker MP170 was used for the measurement of short circuit current and maximum power. And and also open circuit voltage. But in this presentation, I did not take the result for the VOC. So we have used a 100-watt PV panel, and the panel was used for both systems. Track the panel or track the system and the fix the system. In this case, also we have east-to-west solar tracker and fix the angle east-to-west solar tracking. So we have done that in the case of theoretical, and also in the experimental part, we have considered those two tracking configurations. And here are the result of of this study. As I said, this is part of the study part of the study, which was designing of a dual axis solar track optimized for Dar es Salaam, so that to determine the influence of tracking both north-south movement of the sun and east-west movement of the sun, or daily east-west movement of the sun. So in this case here, with east-west solar tracker, the improvement in the energy collection by a PV panel was about 36%, whereby with a fixed angle east-west solar tracking, the improvement was about 27%. As I said, this east-west solar tracker is the one that is following the movement of the sun from from sunrise to sunset. But the second one, fixed the angle here from morning to noon, the panel is directed toward east, and from 12 noon to sunset, the panel is directed toward east. And as you can see here from the figure 1, we can see that March, no major gain around March and September, whereby the sun is almost overhead while crossing the altitude of the overhead of Dar es Salaam while moving to and from the north of Dar es Salaam. So that is figure 1, showing the result of the theoretical part of my study. Coming to the experimental part, here we have the result showing the short circuit current and maximum power for the fixed panel, east-to-west solar track the panel, and fixed the angle east-to-west solar track the panel. As you can see here, also the improvement is 42% in the current for the east-to-west solar tracker compared to fixed the panel, but it is 27% in terms of maximum power. But for the case of fixed the angle east-to-west tracking, the improvement in the short circuit current is 22, and the improvement in the power is 14%. We can see that the improvement in the power is a bit less compared to short circuit current, but this because of the minor improvement or insignificant improvement in the open circuit voltage, but I did not include here in this presentation. But the improvement in open circuit voltage is very small. As we can see here also in figure 2 and 3, between 11 and 13 hours, when the altitude of the sun is high, a fixed horizontal panel harvest more energy compared to fixed the angle east-west tracker, because during noon still, or be at 11, the tracker is located or is facing the panel to the eastward, while the sun is now overhead. And also, so between 11 and 13, we can see here from the figure 2 and 3 that fixed the panel harvest more energy compared to fixed the angle east-west tracking. But for east-west solar tracker, the improvement is higher throughout the day. Though we have less improvement in the power between 11 and 13, still we have seen some improvement, significantly improvement in the energy collection as well as power output by PV panel. So, in concluding, this study have revealed that sun tracking is significantly improved the energy collection as well as power output by PV panel. With the east-west tracking, then maybe you are tracking throughout the day. Maybe it is a cost, especially when using motors, so that the panel is tracking the movement of the sun from morning to evening. So a fixed angle east-west tracking may be the remedy for to reduce the cost. So this is the suggestion as well. So we can see this is the conclusion that sun tracking is significantly improved the energy collection and power output by PV panel, and a suggestion from this study also we can use a fixed angle east-west solar tracker for to remove or to reduce the cost. So up to here, I can this marks the end of my presentation. But before moving, I would like to acknowledge or send my appreciations to CESA, to International Science Program, ISP, SUSA, my employer and sponsor in my MSc study in the University of Dar es Salaam. But also I wish to send my appreciation to the University of Dar es Salaam, especially to my supervisors, Dr. Samiji and Dr. Mluka. Okay, thank you very much.
Thank you. Thank you, Abdul Majid, for the presentation. We appreciate your presentation. Maybe questions from the audience?
Yes, I have a question. Yeah, first, this is a very interesting research. Because of course, there have been concerns regarding the tracking versus the amount of energy which will be required actually to manage the tracker. Now, there is this part where you're talking about manual. So you are just adjusting this yourself. But I'm wondering now the practical implications. If you are now to do it practically, did you consider the fact that the same energy will be harvesting will still go back to actually rotate the tracker? That is question number one. Number two is actually what is happening at 11. Figure 2 and figure 3 shows that there's a dip at around 11 a.m. Yeah. What's happening there? Because in my own thinking, I would assume that from 8, you'll be having an increase, and then you'll have a peak at around 12 to 1, and then now the curve starts going down. So I was expecting a very smooth, of course, some bit of noise, but some kind of a rise and then a fall. So what is happening here? Because it seems to be replicated by the theory. Maybe you can comment on those two.
Okay, thank you. Starting with the second question, yeah, the peak at 11, and yeah, about 15, I think it is obvious. But there was a problem with the fluctuation of solar radiation. I could have introduced a figure that shows how the solar radiation was fluctuating while doing my experiment. And there is a point there, or a challenge which I should address while doing this experiment, to increase the number of days taking the data, and therefore taking average to reduce this problem. But the main issue here is the fluctuation of solar radiation, and it was a very challenging issue that happens during my study. About the first question, yeah, at first we wanted to have an automatic tracker so that we could address the issue of cost, so that we can have a clear picture how much we are going to have while tracking, and compared to fix the panel. But there were some challenges which hindered the automation of that solar tracker. So and then we came into agreement. So in order to have at least a picture and maybe a starting point, let's have this manual tracking so that we can see at least taking, taking into, neglecting some other issues of energy that maybe will be used in operation of the automation, because so many studies have introduced that issue for other different locations that they have conducted that such kind of research, that there are some energy that is used or lost in operation of tracking. So we came into this after taking on, neglecting such issue. But that is a part of recommendation and for future or further studies. Thank you.
Okay, thank you.
Thank you very much. We don't have any questions from the audience.
I've raised my hand.
Yes.
Whoever is chairing, Peter Tutanui, I've raised my hand.
Okay, maybe I was not audible enough, sorry. Kindly proceed, sir.
Yes. Now, can the author go to the page on methodology? Methodology. Yes. My only concern is you explained your methodology. I'm wondering if we gave the same to Dr. Peter Nyawere, Philip Nyawere, to do whether he understood your methodology that he can replicate the same. Because you are not as clear as we expected you to be. And then on the results and the discussion, I have seen quite several spikes. If you could use some statistical method of separating data, it could have given me something called significant difference. But you have indicated they are different without really quantifying the significance using some of the statistical method. Unfortunately, I come from applied statistics, and I can see this is an applied maths. So that is those are my comments. That methodology must be clear so that when you are explaining, if you step down, somebody can repeat the same without you are being there to direct. Thank you.
Okay, thank you very much. I don't know. I think that was a suggestion, and I don't know whether the presenter. Okay, sorry for the interference, and I want to thank Ragama for the comments. I don't know whether the presenter has anything to say about that comment.
I have taken the comment.
Silence means the presenter will take into account. Yeah, okay. Continue, Abdul Majid. Any comment you would wish to make?
I'm still listening to the comment question, but about the issue of statistical data, yeah, maybe I have something to add. I will settle with the supervisors, but there are some, yeah. there are some issues. There are some issues which we have to settle with the supervisors, but in the case of methodology here, I will just try to show how we are going to have these solar beam radiation data on the tilted surface and based on the radiation from for horizontal surface. Maybe okay. I will try to make it look very clear.
Okay, thank you very much. Thank you very much, Abdul Majid and your other presenters for taking us through your presentation. We really appreciate.
Thank you.
So we are going to move on to our second presenter, and that is Kennedy Juma. Somebody has a question. Oh, sorry. Yes, please proceed.
Thank you so much, Chair. To Majid, thank you for taking into consideration that statistical analysis so that you can apply into that methodology. Also, if I may look at your methodology, you'll need to expound further on why you are restricting the values of B on R and H, and where you are using the delta and omega in that square root so that you remain with a constant value. Now, on the same note, your research is so interesting on how you are tracking the sun from east to west. Now, my question is, where do we, or why did you carry this study, and what is its significance? Then two, you may just need to also tell us what could be the components of the sun tracking, if in case you are doing the manual or it is automated. Thank you.
Thank you very much, Wesley. Abdul Majid, you going to respond to that?
Okay, thank you for the question. Yeah, as I said earlier, maybe if I was very clear that there are different literatures showing the impact or influence of sun tracking for different locations with different geographic and climate conditions. But our interest, this study is to show how significant is sun tracking in Dar es Salaam or in Tanzanian localities. And we have done that by comparing the energy received by a tilted panel compared to the energy received by a horizontal panel. And that's the improvement that we have shown the result, about 36 and 22 improvement with different tracking configuration. And that's the significance of that study, that the energy collection can be improved by about maybe 36% and 22% by a by a tilted panel compared to a fixed panel. For the second part, while I answered some of the questions, I said that our target was to fabricate an automatic tracker, but finally we had a manual tracker, so that at least to have an overview, a starting point of how significant sun tracking could be. And it was taken as a challenge or suggestion or recommendation for further studies to find the improvement or influence of tracking using an automatic tracker, so that we can have a clear picture of influence of sun tracking, and taking into consideration some of energy that will be lost in operation of using automatic tracker. Thank you.
Okay, so what are the components?
Sorry, component, sorry, can you elaborate that? What do you mean maybe by component?
Wesley, maybe the presenter is asking that you elaborate.
Okay, so what I mean by asking for the components is that I'm assuming this is a kind of a model which is found in your tracker. So I'm assuming
Sorry, I'm not hearing.
so that you are able to monitor. So that is my question.
So I don't know whether that is clear, Abdul, and we are kind of running short of time. We need to move on to the next presentation. But I don't know, is the question clear to you now?
No, I didn't hear, but he was started to explain, but
You are not getting
then it was muted. I didn't hear. But but from my understanding, while he was starting to
Recording
explain,
stopped.
maybe I can say the component here were the incident angle. I mean, the incident angle of the solar radiation incident on the tilted panel, which is theta, and also the other component is
Recording in
the
progress.
zenith angle. These are the important components so that we have this radiation beam tilt factor. As I said in the question one, this one relates the radiation received by tilted panel or collector from the radiation received by a horizontal panel. And this is we can say this is the input, and this is RB is obtained from theta and theta Z. So if I got it clear, these are the very important component. Theta, I mean angle of incident of the solar radiation beam, and theta Z, which is the zenith angle. And this cos theta Z and cos theta, these are the equations which show how cos theta or theta and theta Z can be calculated. Thank you.
So thank you very much. I think in the interest of time, we are going to move on to the next presenter. And let's stick to the time, 15 minutes. I think Abdul Majid presentation has taken 30 minutes. If we do that, we may not be able to actually finish. So may I call upon Kennedy Juma to take us through? Kennedy Juma, are you with us?
I'm there, Doctor. I'm trying to share the screen.
Oh. Welcome. 15 minutes.
Okay. I don't know if it's clear.
You can put that on slideshow so that it's more clearer from the beginning.
Then I'll put slideshow. But
From the beginning. Yeah.
Slideshow from the beginning. Yeah. Is it clear from the end?
It's not responding. Just proceed, Kennedy.
Is it moving?
Yeah, it's not moving, perhaps. Yeah, you can proceed, Kennedy. We are not hearing you.
Is it okay from the other end?
Can you unmute? Kindly. Kennedy, kindly unmute. Yes, Kennedy, we are not hearing you.
Is my screen visible?
Yes, it is visible.
It's moving.
Okay.
Want you to talk.
Kennedy, can you disable one gadget, because you seem to be using two gadgets?
Yeah, I'm using two gadgets.
You can disable one. Yeah, you can therefore unmute and proceed. We are not hearing you, Kennedy. Have you unmuted?
Okay. Are you getting me now?
Yeah, proceed.
Okay, thank you very much. I'm looking at the structural stability of lithium silicon bromide for optical spectral applications using the HSE study. HSE simply means the hydrocyanide.
You are not audible enough. Kennedy, can you increase your volume if possible?
I'm looking at the structural stability of lithium silicon bromide for optical spectra applications using the HSE study. HSE simply means the hydrocyanide radical method. Now, the advances of perovskite materials for solar cells applications have grown exponentially in the recent past. This has attributed to the success of some of the metal halide perovskites that have shown significant solar conversion capability. Unfortunately, with the application of the toxic lead in such compounds, it hinders their real technological applications. Therefore, to model the potential solar cells beyond lead and tin so that they can be able to find applications we applied the numerical atomic optical method for the basis set treatment as implemented in the SESTA method to calculate stability, and also the optical spectra in the cesium silicon bromide and cesium germanium bromide materials. Our findings revealed that these materials have competing energies in the individual phases, with the cubic phases dominating the high but wide temperature regime. The optical spectrum obtained showed very strong optical activity in the visible light. So this work shows the technological importance of these materials, especially in the solar industry. We looked at these materials. Basically, we are looking at materials which are of importance to the solar materials. So the metal halides have shown significant behavior, especially in the solar conversion capability. Unfortunately, with the application of lead in such compounds, it has hindered their real technological applications. So we have made a model of the solar cell materials beyond lead and tin that may find applications in our real life situations. We employed the numeric atomic orbitals for the basis set treatment as implemented in what we call the SESTA method to calculate the stability of these materials and their optical spectra. Our goal was basically to look at the stability and the optical spectra of these two materials. So one, we were able to solve the Monaghan equation of state for these materials, calculate the electric band structure, and then also calculate the mechanical hardness. This work was limited to the DFT ambient conditions, that is 0 Kelvin for temperature and 0 gigapascals for pressure. The outcome is based on high order theory as implemented in the Hay-Skak-Surya Esan scheme. This project focuses on the structural, electronic, band structure, and mechanical hardness of cesium silicon bromide and the cesium germanium bromide. It's a computation project, so we employed the DFT as implemented in the SESTA code in this study. We employed the GGA according to the Paddy-Park-Eisenhower parameterization, which was used to determine the exchange correlation function. We also employed the Brilliant zone sampling on the non-cost pack of mesh 16 by 16 by 16. The cone-sham orbitals were also obtained by the structural ability, by obtaining the structural ability and the electronic properties within the DFT as implemented in the SESTA code. I looked at the structural optimization. It was expected the GGA employed herein will underbind the lattice parameters as shown in the table. When you look at the table, the results from the GGA and the HSE, they compare very well with the existing data from other codes. When you look at the GGA values for the cesium silicon bromides data is 4.8. So when you look at these results, they show a comparison, which is very, very clear. Now, when you look at the electronic band structure, where I used the Fermi energy and the K points. The K points are simply the high symmetry points. So the calculated electronic gaps are as shown from the GGA, the HSE, and the experimental data. When you look at this, the values from the GGA and the HSE, they are not very far from the experimental data. This one shows that the band structure for the cesium silicon bromide shows that the materials have metallic structure. This band gap between the conduction and the valence band also it's too small, meaning that there is an overlap. Cesium silicon bromide has a wide band gap, which I've said is comparable to the experimental data. We also looked at the part band description of the active orbitals, and the total energy was also calculated as a function of the unit cell volume around the equilibrium cell volume. We used the software of the XM Grace that helped us to come up with the structures. The band structure was simulated by using the brilliant zone and the bands plotted using the respective K points. To check the mechanical stability of these materials, we employed the bond
Kennedy, we seem to have lost you. Are you with us? We seemed to have lost the presenter. Maybe the presenter is facing some challenges associated with connectivity or something like that. Kennedy, can you proceed?
I hope I'm back. Sorry. So to check the mechanical stability of these materials, we employed the Born criteria, which consists of the four listed equations. When you look at the equations, the values obtained, all of them were greater than 0. That one means all of them are mechanically stable, meaning that they can be fabricated.
So I think Kennedy seems to be experiencing challenges which we may not be able to know.
So on conclusion, I think I'm on my conclusion. Our findings reveal that the materials have competing energies in the individual phases.
Kennedy, can you share the screen?
Is it okay?
Yeah.
So sorry for technical problem. I was saying our findings reveal that the materials have competing energies in the individual phases, with the cubic phases dominating the high to wide temperature regime. The optical spectrum obtained shows very strong optical activity for light regime, hinting that these materials are potential materials for solar cells. This work shows that the technical importance of the selected materials in the solar cell industry, and that there's need also to calculate the solar conversion efficiency of these materials. So basically I've looked at the energy, the band structure, and the mechanical stability of the silicon bromide. This work is part of my research work. It's at the proposal stage, and the findings will help me also to determine the characteristics of the silicon bromide and recommend it as part of a solar cell material. Those are some of the references which I used. So lastly, recommended to the Center of High Performance in South Africa, and also to my University Kabarak. Thank you.
Okay, thank you very much, Kennedy. So there was a lot of challenge in the presentation, perhaps associated with the network. So from the audience, any questions? Just in brief, in the interest of time. Any questions, Kennedy? Yeah, Daktari, Cecil, our key our guest speaker, Dr. Cecil Ouma, has a question. Kindly proceed, Daktari.
Oh, okay. Can you hear me?
We can hear you, Daktari.
Okay. No, for me, I had like several comments, not necessarily a question. Based on the results that he has presented, I still don't believe that material is good for optical applications. He still has to go further and work on the reflection spectra, the absorption spectra, and the rest. And then he also needs to refresh on the theory, because when he was talking, I heard him talk about something like the siesta method. There is no siesta method, which is just a code. The methodology he used was DFT. And then also you don't calculate the equation of state. You fit the equation state using the data that you have. So maybe the student just need to refresh a little bit more on the theory so as to make the work have more oomph. Thank you.
Thank you very much, Daktari, for your input. I do believe that Kennedy is taking down the sentiments to improve that particular work. Thank you very much, Dr. Uma. Any other comments? And I hope third presenter, that is Ian Mwangi, is ready, because after Ian Mwangi, we will have our guest speaker. So is Ian Mwangi with us? You are here? Okay. So if we don't have any question concerning Kennedy Juma's presentation, we will invite Ian Mwangi, our third presenter, to make his presentation. And let's also take care of time. Let's make our presentations within the provided time. The presentation together with the questioning session should take not more than 15 minutes. Let's take note of that. Let's manage time. So I think the third presenter, Ian Mwangi, is actually ready. So you may proceed. So we are actually waiting for third presenter, Ian Mwangi, to present.
All protocol observed. I'm Ian Kamau, and today we will be looking at first principle, study of structural and electronic property of antiperovskite calcium hydroxide. I'm Ian Kamau, and my supervisor is Dr. Philip Nyawere. So that is the table of contents. I will be starting at the abstract, introduction, literature review, research, design and methodology. Then we'll go to the results and later in reference. So we'll start at abstract. Antiperovskite compound consists of two types of anion coordinate with one type of cation. Antiperovskite compounds are an important class of material because they exhibit interesting and useful physical property not found in perovskite material, and that's the only reason we give we'll be looking at antiperovskite material or compound. I don't know if you can see. Okay. So antiperovskite material have a wide range of application, especially technology. And that's the only reason that we gave a focus on this material, especially calcium lead oxide. The study of structure and electronic property of calcium lead oxide in cubic inverse perovskite phase is here studied using the first principles density function theory, which in shortcut we can say, in abbreviation we can say DFT, as used later on the slides. Our calculation were performed using a software called Quantum Expressor, code based on density function theory. The general formula of antiperovskite compound is A with a 3, B, O, where A sites are occupied by an electropositive ion, while where A and B sites are occupied by different size anion. Antiperovskite have shown various interesting properties, such as magnetism, ionic conductivity, superconductivity, and other utility. And those are some of the reasons why we decided to give that one a look at. The study of antiperovskite material have attracted wide research interest because of their unusual high charge carrier mobility, and consequently leading to many technological applications. Yeah, the band structure calculation of calcium lead oxide and its family have found the three-dimensional massive Dirac electron exists at the Fermi energy using Wayne 2K. So as you can see, there's an image there. The main objective of this study is to compute through first principle the structural, thermoelectric, and electronic property of the antiperovskite calcium lead oxide. This finding, or the finding, shall be beneficial in advanced technology, such as application in environmental friendly power generator and refrigerator. So we'll look at the literature review, where antiperovskite calcium lead oxide is predicted to be a three-dimensional Dirac fermion system. Calcium lead oxide is a cubic perovskite structure and crystalline in the cubic PM3M space group. Calcium lead oxide belongs to space group FM3M and possesses an oxygen atom surrounded octagonally by calcium atom, as shown in the figure. That is the figure of the structure that we found. The formation Dirac cone at the gamma point confirms that calcium lead oxide to be a Dirac semi-metal. Technology is highly used, hence leading to high demand of technological equipment. Therefore, need to look at the material with high charge carrier mobility. Calcium lead oxide belong one of the best high charge carrier mobility, can be used in making many equipment such as generator and refrigerator and many more that are not included here, which require high carrier charge mobility. Therefore, there is a need to study property of antiperovskite calcium lead oxide. So research, design and methodology. A computer software, Quantum Espresso, will be used to undertake this scientific research. First principle calculation of structural property of calcium lead oxide using generalized gradient approximation, GGA, that's an abbreviation, will be used. Quantum Espresso is an acronym for open source package for research in electronic structure simulation and optimization. It is integrated suite of open source computer code for electronic structure calculation and material modeling at the nanoscale. Still at the research, design and methodology, Quantum Espresso is a suite for first principle electronic structural calculations and material modeling, and is based on density function theory, plane wave basis set, and pseudo potential, both normal, conserving, and ultra soft. The structural property are obtained using generalized gradient approximation, employing pseudo potential and plane wave basis set. So after doing that research and methodology, these are the results that we got. So the first you can see a table. This is a lattice parameter and unit cell volume of cubic antiperovskite calcium lead oxide is presented in that table. That is table number 1. So you can see that the GGA was 4.87, and the experimental, you can see that experimental was 4. And abinite was 4.88. So these are the results that we got from this. You can see that is from this work. Yeah, this one is from this work, and you can see that this was what we got from this work. As compared to the experimental, which we have not yet, according to the experimental, is almost approximation with what we got. So meaning that you're in the correct track, and yeah, and that one are correct. The one that you got by stimulations. So for the result number 2, for that is the figure that we found, and that's the structure in 3D, even though it is painted in 2 dimensions, but the 3D structure is that one. This figure shows the optimization of this one, shows the optimization of lattice parameter against the energy. The lattice parameter was found to be 9.199 Bohr, which is equal to, that's approximately, if you convert into it becomes 4.87, and the volume is 248.858. Yeah, as you can see, the color for gray, this one, for the gray was lead, and for the blue, this one here was calcium, and for the red, this one here is oxygen. So this figure here down, this one. For the figure, this one here shows density of states in electron per electron volt. This figure number 3, the Fermi energy level is fixed at the origin. As you can see that it's fixed at the origin, and the graph is that one that we found out to be that one. So as we can look at for table 2, elastic constant and constants and Russell's high average parameters. So you can see this one for C11, this one. We got from this study to be 97.68. And also this one for C12, we got to be 28.71. We got from this study. And C44, we got that to be 49.07 for 0.09 GPA from this study. So those are the results that we got, and those are the reference.